In this chapter, we will discuss round and out of round rims, when to correct roundness errors, and a concept of the wheel as a teenager. An important point to mention is to avoid premature intervention. There comes a time when the moment is primed to set and balance spoke tension. I like to use analogies, and one analogy I often use when I'm teaching somebody how to build a wheel is to consider the wheel as a teenager. Now, what do I mean by that? Well, let's say the analogy is this. Let's say that you have a child and you're trying to instill in your child some concepts of, let's say, being a good worker, showing up to work on time, and honoring your employer, doing a good job, and things like that. If your child is 5 or 6 years old, the child is too young. On the other hand, if you wait until the child is in his mid-20s, maybe it's too late to instill that good work ethic. So perhaps the teenage years are the time to try to influence the child in a positive way. The analogy for wheels is this. When you're tensioning the wheel, if the spoke tension is too low, let's say you're just starting out and you start getting a little bit of tension and you see that the wheel is out of true, or that the spoke tension is not even and is not balanced out, that is too early to make the changes. The wheel is not ready yet to be influenced in that way. On the other hand, if you wait until the wheel is an adult, it's reached full tension, perhaps the wheel isn't going to be easily adjusted at that point. The best time to do those things, to adjust the wheel, to balance out the tension, to get the hops out, to get it laterally true, and so on, is when the wheel is a teenager, which is about 3/4 of the way toward the tension on the drive side. If you do that, you'll find that many of the problems that you might have been tempted to react to prematurely will have gone away as the wheel tries to distribute the stress within itself. Try that, and I think you will avoid a lot of problems that lead to unintended consequences. Sometimes by reacting too soon, you create a problem that otherwise would have gone away if you'd left the wheel alone. For example, if this is my wheel and my goal is on the final tension on the drive side to have 1200 newtons, which is about 120 kilograms of force, my tension at the 75% point is going to be at 900 newtons or 90 kilograms of force. This is the graphic you'll see in the next couple of slides. The rim is red, the spokes are blue, and the nipples are green. Here's a wheel that I've got maybe 1/3 tension, and I started with a perfectly round wheel and laced it up carefully, consistently tightened the nipples, so I should enjoy some pretty good consistency in the intermediate tension that I can measure and feel on these spokes. Here is the same scenario, except in this case here I have a rim that is not totally round. In the major axis, I have a dimension of 630.25 millimeters. In the minor axis, 629.75. So I have a difference in those two dimensions of about 1/2 millimeter. Even if I have very carefully turned my nipples onto the spokes, I will find that these spokes here are going to be tighter and have more tension on them than these, which will feel looser. The job of the wheel builder is to make the wheel round, even if the rim doesn't start out that way. If you just screw these nipples in here to make the tension on those spokes like the tension on the other ones, you will lock in that out of round condition. But if I ignore that temptation to try to prematurely balance out the difference in the tension, and I keep tensioning my nipples consistently, then the additional tension and stress on these spokes will be redistributed within the wheel, and the sides will pull in and the top and bottom push out toward roundness. So again, if I start out with a perfectly round rim and I consistently tension my spokes by equal turns of the nipples, the rim is going to stay round. But if we start out with a rim that's out of round and we ignore the differences in the spoke tension in the early going, the wheel will move all by itself toward roundness. Let's look at some examples of when the wheel is at static equilibrium, meaning that it's at rest and the vector sum of all the forces in the wheel adds up to 0. This is a graphic of a wheel that actually doesn't have any forces on it yet. It's a perfectly round rim. All the spokes are of exactly the same length, and all of the nipples are to the same starting point on every spoke. We tension the spokes with perfect consistency, equal numbers of turns, and the tension on the spokes pulls the rim inward, but the rim, we know, is itself elastic, wants to return to its original shape, and that gives us these opposing forces here. The wheel is at static equilibrium, and the sum of all the vector forces is equal to 0. Here is my wheel at final tension, and all of the inward forces are the same, and all of the outward forces are the same. They all cancel out, and the wheel is also at static equilibrium. My wheel is round, and all of the spoke tension is exactly balanced out. Here's a wheel that started with a rim that is obviously way out of round, but I have used exactly the same lengths of spokes in lacing up the wheel, and I have all of the nipples to exactly the same starting position. Here is my wheel at an intermediate tension. I have put all the nipples on, screwed them on to exactly the same number of turns. 8 of the spokes now have some tension on them and 8 do not. The wheel is nevertheless at static equilibrium because all of the sum of the tension on the spokes is equal to 0. My wheel is not yet round, but it's better than it was in the first picture. And here's my final wheel at static equilibrium. Lo and behold, I've gotten the rim round, but only at the expense of the consistency of the spoke tension, because the spokes at the left and right side of the wheel are much, much higher than at the top and bottom. We're going to see what happens when we try to ride on these wheels. Both of these are identical, the same weight, the same normal force. Whatever I deem to be a good, strong average tension for the wheel, the one on the left will have all of its spokes at or very near that average tension. But obviously the one on the right to have the same average, some of the spokes are going to be massively over-tensioned and others almost too loose. Let's look at these wheels as they turn and see what happens particularly to the tension on the spokes as they go through the load-bearing zone. This wheel here is going to give me consistent fluctuation of the tension on the spokes as they go through the load-bearing zone. But the other wheel over here, because the tension is inconsistent to start with, I'm going to have an inconsistent fluctuation of tension. No rim will be as out of round as the one shown in green in the lower left, but what this tells us is that if we start out with a rim that is out of round, even if we can end up with a wheel that's perfectly round, it will be at the expense of the consistency of the tension on the spokes.